Introduction of the topic, techniques of differentiation. Differentiation is a fundamental concept in calculus that measures how a function changes at any given point. In simple terms, it tells us the rate of change or the slope of a curve. For example, in real life, differentiation helps us determine how quickly a car's speed is increasing, how population grows, or how temperature changes over time. To make the process of finding derivative easier and more systematic, the mathematicians use several techniques of differentiation. This includes the power rule, product rule, quotient rule, and chain rule, which help us differentiate different types of functions efficiently. There are also additional techniques such as implicit differentiation, logarithmic differentiation, and differentiation of trigonometric, exponential, and logarithmic functions. For question 1, differentiation, also known as the derivative of a function, is often interpreted as instantaneous rate of change. Explain the statement above and provide a real-world example where calculating rate of change is crucial. Differentiation, or finding the derivative of a function, gives us the instantaneous rate at which a function output changes with respect to its input. In simple terms, it tells us how quickly a quantity is changing at a specific moment. The meaning of differentiation is a fundamental operation in calculus that can measure the sensitivity of a function output with respect to change in its input. The derivative of a function at a specific point represents the slope of the tangent line to the function graph at that point, where the instantaneous rate of change is the rate of change at a particular instant. Unlike average rate of change, which is calculated over an interval, the instantaneous rate of change captures the process rate at a single point. Where, for example, is velocity. Consider the motion of a car. The car's position as in the bracket of times change with time. The derivative of the position function is dx over dt. That gives the car's instantaneous velocity at time. Knowing the instantaneous velocity is crucial for controlling the car, especially in situations where quick reactions are necessary, such as avoiding collisions or maintaining a set speed.
For question 2, we need to find dy over dx for the following functions. So we start with question A. 2x cubed in bracket cos 3x square. So we need to find the dy over dx, we use product rule. We let 2x cubed become the derivative u, and in bracket cos 3x squared become the derivative v. We start with derivative u. Du over dx equal to d over dx in bracket 2x cubed. We differentiate it, become 6x squared. For derivative v, dv over dx equal to d over dx in bracket cos square 3x. Next, we need to apply the chain rule. From the formula given, the answer is dv over dx equal to 2 in bracket cos 3x times in bracket negative 3 sin 3x, which is equal to negative 6 cos 3x sin 3x equal to negative 3 sin 6s. So next, we need to use the product rule. The formula is dy over dx equal to u, dv over dx plus v, du over dx. The answer we will get is equal to 2x cubed in bracket negative 3 sin x plus in bracket cos 3x squared in bracket 6x squared. Lastly, we simplify the answer. Dy over dx equal to negative 6x cubed sin 6x plus 6x squared cos square 3x to 6x squared in bracket cos square 3x minus x sin 6x as the final answer. For question B, we apply the logarithm properties. So we let y, using the logarithm properties, ln in bracket a over b equal to ln a minus ln b. So y equal to ln in bracket e square x minus 3 minus ln in bracket 1 minus 4x. So next we differentiate with respect to x. Dy over dx equal to d over dx in bracket ln in bracket e to e square x minus 3 minus d over dx ln in bracket 1 minus 4x. Next we apply the chain rule. For the first term, we let u equal to e square x minus 3, then du over dx equal to 2e square x. So we get 2e square x over e square x minus 3. For the second term, we let v equal to 1 minus 4x, then dv over dx equal to negative 4. So we get negative 4 over 1 minus 4x. So next we combine the derivatives. So we get dy over dx equal to 2e square x over 2 square x minus 3 minus negative 4 over 1 minus 4x. We get 2e square x over 2 over e square x minus 3 plus 4 over 1 minus 4x. Lastly, we simplify the equation. Dy over dx equal to 2e square x in bracket 1 minus 4x plus 4 in bracket e square x minus 3 over in bracket e square x minus 3 in bracket 1 minus 4x. The final answer is 6 dy over dx equal to 6e x square minus fxe x square minus 12 over in bracket e square x minus 3 in bracket 1 minus 4x.
As for the question 3, given y squared to e to the power of 5x plus cosine of xy equals to plus natural log of x plus 1, we need to find dy over dx using implicit differentiation. We start by differentiating the left hand side. Differentiate y squared e to the power of 5x. This is a product. Let u equal y squared, v equal e to the power of 5x. Then du over dx equals 2y dy over dx. And dv over dx equals 5e to the power of 5x. Product rule, 2 times d over dx plus v times du over dx gives y squared times 5e to the power of 5x plus e to the power of 5x times y dy over dx, which is 5y squared e to the power of 5x plus 2y e to the power of 5x dy over dx. As for the part b, we differentiate cosine of xy. Using the chain rule, derivative of quotient of something is negative sine of that something times derivative of the inside. Inside is xy, so negative sine of xy times derivative of xy. Derivative of xy is product rule. Y times 1 plus x times dy over dx. So y plus x dy over dx. Therefore, negative sine of xy times y plus x dy over dx, which distributes to negative y sine of xy minus x sine of xy dy over dx. So that's the complete differentiation of the left hand side complete. Now the right hand side. Derivative of 2 plus natural log of x plus 1 is just 1 over x plus 1. Combine everything, the differentiation left side equals the right side derivative. So 5y squared e to the power of 5x plus 2y e to the power of 5x dy over dx minus y sine of xy minus x sine of xy dy over dx equals 1 over x plus 1. So we expand and collect terms with dy over dx. We get 2y e to the power of 5x dy over dx minus x sine of xy dy over dx plus 5y squared to the power of 5x minus y sine of xy equals 1 over x plus 1. So we group the dy over dx terms. 2y e to the power of 5x minus x sine of xy dy over dx equals 1 over x plus 1 minus 5y squared e to the power of 5x plus y sine of xy. So the final answer is dy over dx equals 1 over x plus 1 minus 5y squared e to the power of 5x plus y sine of xy, all divided by 2y e to the power of 5x minus x sine of xy.
For question 4, use linear approximation to estimate the value of 255.1999 in the square root plus 1 over square root of 255.99, correct to 4 decimal place. The answer is 16.2469. For the explanation, step 1 is define the function and identify the point of approximation, where the function be f in the bracket of s equals to square root of s plus 1 over square root power of 4x. We want to estimate the value of f in the bracket of 255.99, where we choose an arbitrary point where the function is easy to evaluate, which is s equal to 256, and the change in s is ds of ds equals to 255.99 minus 256, which is equals to negative 0.01. For the step 2, we are going to calculate the derivative of the function, where we rewrite the function as f in the bracket of s equals to s power of 1 per 2 plus s power of negative 1 per 4. For the derivative, we are using the power rule, which is the f prime s in the bracket equals to d over ds in the bracket of s power of 1 per 2 plus d over ds in the bracket of s minus 1 per 4, where the answer is, after that, following the solution, we are going to get f prime s in the bracket equals to 1 over 2 square root s minus 1 per 4s power of 5 per 4. For the step number 3, we are going to evaluate the function and its derivative at the chosen point, where the s equals to 256, and where at the s equals to 256, we are going to use square root s equals to square root 256, where s equals to 16, and for the square root power of 4s equals to square root power of 4 256 equals to 4. So f equals to 200. So f in the bracket of 256 equals to square root 256 plus 1 over square root 4 of 256 minus 16 plus 1 per 4 equals to 16 plus 0.35, where the answer is 16.35. Next, we are going to calculate the f prime 256 in the bracket, where we are doing the solution, and we will get the f prime 256 in the bracket equals to 1 over 32 minus 1 over 4096. To subtract these fractions, we must find a common denominator, which is 4046, where the equation will be f prime in the bracket of 256 equals to 128 over 4096 minus 1 over 4046, where the answer is 127 over 496. Next, we are going to calculate the differential of df. The differential of df is given by df equals to f prime s in the bracket ds, where we will get the answer is negative 0.0031, where will be the answer is negative 0.0031, where we will be rounding to 4 decimal place for the purpose of estimation, so we can consider this value correctly. Next, we will estimate the value of f equal f in the bracket of 255.99, where the estimate value is given by f in the bracket fx plus dx in the bracket. We will get fs in the bracket plus df, and then with the solution I've done, we will get the answer is 16.2496 for the answer for the question number 4.